Hello everyone, welcome to your next chapter and section. In this chapter we're going to be learning about lists, dictionaries, and looping. These couple of concepts are extremely important for programming because this is what's going to allow you to start automating your code. So you're going to be able to now start to do things like rapid processes that no human could possibly run on their own at the same speed that a computer program can. So you're going to start to actually see some of the power of what Python and programming language can actually provide for you, especially within data science. So you're going to learn about a couple of data types that we use for for loops and while loops a lot. And then I'm going to introduce you to what those loops actually are. And then lastly, we're going to go through a couple of tips and tricks for how to make sure you optimize your loops and your lists properly. So I'm really excited for this chapter, guys. You're going to find that it probably is a step up in terms of the amount that you're going to need to learn and process, but it's really fundamental and important stuff. And if you get this down, you're going to be well on your way to learning a lot of the fundamentals of data science and code. And you're going to start to automate things in really cool ways. So what are we going to learn today, guys? Today we are going to learn about lists and tuples. These are two new data types that you have not been exposed to yet. You're really going to learn about lists for the most part because tuples are very similar to lists. So you're not going to learn, it's almost like our integer and float lecture in that, yeah, you learn two data types, but they're very similar to each other. I'm going to show you how to index lists, like we learned how to index strings. That's a very important feature of dictionaries and lists, is being able to extract the information that you want from them. And then finally, we're going to go over a handful of functions that you can use with your lists in order to get some information out of them. Okay, so let's go into our definitions here. First, what is a list? A list is sometimes called an array in other programming languages, but you can effectively think of a list as just an object that can store other objects. It essentially will hold any amount of integers or strings or any other kind of object that you want, and it contains it within this object. You can almost think of it as like a variable that holds a bunch of other variables that you can then do automated processes on. So the technical definition of a list is that it's a mutable, ordered collection of variables indexed by their position in the collection. So what that all means is what we mean by mutable means that we can add and remove and change elements of our list on the fly. We can, manipulate what goes in and what comes out. Next, it's ordered, meaning that if we put objects into our list, when we put them in the list and where we exactly put them in, at the beginning of the list, the end of the list, in the middle, second position, third position, that information is preserved, and it's what we use in order to index and find values within lists. When we move into dictionaries, you'll realize that they are unordered collections of variables. So, and there's a whole other indexing system that is involved in that. So it's important to understand the distinction between ordered and unordered collections of variables, because we do have different data types for those. What makes tuples different from lists is that they're immutable, meaning that once you make a tuple, you can't add to it, remove it, or change it in any way, but it is still ordered by position like lists are. The reason why we have tuples is that lists take up a lot more memory and it's harder to process for a computer. And so oftentimes when we're passing information between functions or other processes across our coding languages, we usually wrap them in tuples. Like we send information as a tuple because it's lighter and faster and does the processing that we want quicker. And if we're not really interested in, changing features of that tuple, we're just passing information around, it's a lot better to use that as opposed to a list. Also, the protection that it's immutable allows it so that if you're passing it around as a tuple, nothing can come in or out of that package of information if you don't want it to. It's like explicitly hard to change information in a tuple. So with that, let's go into some syntax, guys. So I'm going to draw some stuff out for you. You're going to learn the syntax of a list. Okay, everyone, here we are. So first thing we're going to do is look at the syntax of a list. You'll notice that in order to initialize a list right here, this is our initialization. First, in order to create a variable, remember, we have to label our variable here. We're calling our label first list. We use the assignment operator, And in order to create a list, you use these square brackets, which are located just above your, or just to the right of your P button on your keyboard, above your Enter button. And then what we're doing here is we're initializing a list with nothing in it. It's an empty list that has no values in it at the moment. Just to show you how the syntax of this works, okay? The syntax for a tuple is very similar. So you initialize your variable, you use the assignment operator, and then you call a tuple by using just regular braces, which are located on your 9 and 0 buttons when you press Shift. And remember, with a list, we can augment this. We can play with it. Once this list has been initialized, we can add things to it and use a bunch of interesting functions. But with tuples, we're going to have a lot more limited functionality. They work like lists, but they're not mutable. So any kind of mutable functions that we're going to learn about in our list once we get into our code are going to be, specific to lists here. And we're going to mostly focus on lists for this class. We just want to introduce to you what a tuple actually is. So that's important because you're going to see them when you start to build your own code. So I'm going to reinitialize our list, our first list, and put some information into it. And this is how the syntax of that goes. So we go first list, assignment operator, and then we're going to say we want to create a list with these elements inside the list. At the moment, we have 3 integers inside this list, and they're delineated by these commas, meaning that this is element 1, and this would be index position 0, element 2, and so on like that. Now, one thing in this list that is not apparent is that you can have mixed types. So even if we have 1, 2, 7, we can also have a string in there. String. We can also put another list in there. Let's just put an empty list. You can put in any object type into your list. It doesn't matter what it is. Usually when we work with this stuff in data science, it's fairly consistent. So at least the list has some sort of consistency that we know that the elements are all integers, or the first and second position are header names or something like that. But that said, there is no restriction on what you can put into a list. If it's an object, it can go into a list. It doesn't have to be the same object type or the data type for the entire list. And that's really what I want to suggest here. The next thing I want to show you is how one function for lists, which is this .append function. So when we go into our code, we're going to see a couple other functions that we can use. But for lists, what append does is it will add whatever element you want to the end of your list, for whatever value or object you want. In this case, I'm getting it to add the string tree to the end of this list. All right. So now this list should contain 3 numbers and the word tree, and it's all delineated by commas, remember? So now we have 4 elements if I was to do this append function. Lastly, the syntax I want to show you for this stuff here is all about indexing. So remember in our string class, we were dealing with indexing for character positions, so that this 0th position, if we were to use tree as a string, it would just return t, because the positions here for a string, if we were to index, would be, each character. But rather than each character being an index position in a list, it's each element. So I was showing you up here, 0, 1, 2, as the index positions. What this code does is the same syntax for extracting character positions from a string, but rather than extracting character positions in a list, it's going to call just the elements attributed to those index positions. So in this case, if we were to call this, it would return just 1. You can consequently do the multiple element indexing call here, just like we did with strings, where it's you want the element in the 0th position up to the element in just before the 3rd element. So in this case, what we would get is 1, 2, and 7 returned to us as a list. Now this is different than in a string. Remember, with a string, when you ask for index position, you got a single string character back. This will return to you a list with just the values that you requested within it. If you just requested one value like this, it'll just return the one value. It won't return the one value in a list. But if you do this kind of multiple indexing, it returns it as a list. Okay, so why don't we now hop into Python, guys, and play around with this a little bit more and see what's available to us. Okay, so here we are in Terminal, guys. Remember that I'm on a Macintosh computer, so my command line is called Terminal. If you're on a Windows machine, your command line is going to be called Command Prompt, and you're going to want to navigate into Python. You'll see this tilde here. Oops. This tilde is describing that I'm in my home directory at the moment, and this is the name of my computer. So this knowing where your home directory is going to be really important, especially for the next chapter when we start to learn how to script in Python. So I want to kind of like keep hammering that home and remind you what's going on there so that when we get to that chapter, it's going to be very familiar. So now let's go into Python. First thing we're going to do is we're going to set our first list as an empty list and our first tuple as an empty tuple, just like we did in our syntax, and check out what is going on there. So we do indeed have these official data types called lists and tuples. Let's look at some of the functions. Well, actually, first let's just play around with syntax a little bit more, and then I'll show you the functions that are available. So let's actually create a list with some values like we did before. Remember that in order to have multiple values in a list, you need to delineate them with a comma. They're wrapped around these square brackets. Very good. Let's see what comes out of here. 1, 2, 7. Okay, so you do see here that when we call this, it's returning a list because the square brackets are there. If we were to then ask for the 0th position item, which would be the first position, because that's how we index in Python, we start from 0. It's going to give you a 1. If we do 2, it should give us a 7. What happens when we do 3? It says index list out of range, meaning there's nothing in a third position. So it errored out saying I can't find it. Let's also now look at some functions in Python. So we're going to go help and look at what we can do with lists. Remember that when we're looking at the class object lists, that we want to ignore, and looking at this help feature in general, we want to ignore everything with these double underscores here, because these are initialization scripts or initialization commands for this object. We don't actually use these functions at all. It just helps create the function, the object itself. But look here, we have our append function so we have our list, and we go .append and add a new object to it, and it says that object, it will append that object to the end of our list. We also have copy, where we can copy a list using a simple command. We have count, where if we can have it count the number of times an integer exists in a list. So if you have a very large list and you want to see the amount of times 33 shows up, you can use the .count function. We have .remove, which will allow us to remove values in our list, and we also have sort, which can sort all of our data, which is useful for some things as well. Okay, now that we've looked at a couple of these functions, let's play around with this a little bit more. In order to exit out of our help menu, we press Q, and we still have our list here. So let's start playing a little bit with some of these functions. First and foremost, let's try that append function. So we're going to do append tree and see if that is now in there. Now notice that I didn't save this variable. I kind of ran a function onto the variable, and it added this thing here. So if I were to do fl plus a new list house we'll have in here, it will indeed show you can add, so this is something where I'm showing you can use an arithmetic operator on two lists, and if you do an add two lists, it will merge them together. However, because we didn't save this variable, we just said let's add these two lists and see what comes out. It doesn't preserve the second part of the list. So in order to do that, we would have to do like fl equals fl plus house. And now that will indeed show up. Or, if there were, this works well if you have lists with multiple values. You could just append each of them one at a time. But let's say you have, two lists with at least 30 values. You don't want to be appending 30 values into the original list because it's inefficient and it'll take forever. You could use a for loop, but you'll learn about that in a second. Okay, so this is what we've learned so far. We've played with append. Let's see what else we can do here. Let's try that sort function and see what happens here. sorted. Is it sort? Oh, no, it's fl.sort. Right? So how do we use the sort function? We use sort key none stable. L.sort. It should just work. Oh, fl.sort. So what it's saying here is that it can't sort between instances where there are strings and integers. So let's actually just do a new list, 3, 1, 8, and see if that will work now. Yeah, okay. So what it was erroring on, it was saying that it can't sort because it doesn't know how to sort integers and strings between each other. Let's pull this up now and look at that. It sorted our values. Consequently, you can also use a different, there are a few different functions that you can use for that. Lastly, I want to show you the remove function. So we have 1, 3, 8 here. If we wanted to remove some element, we can use the .remove feature, and we can go .remove 8. And see what happens. 8 is actually removed. Okay, let's play with tuples a little bit so you can see how tuples are working. So we have our first tuple here. It's an empty thing. Let's see if we can append 3. No, we can't append. So let's go into our help menu and look at what we can do with tuples out of the box with Python. It seems to be that we can only count the amount of times that an integer occurs in a tuple and find the index value for a specific value within a tuple. So let's try and create a tuple with some values in it. 3, 7, 8, 4, 7, 9, and we can go dot index, find the index for if there's a 7 there, and saying, oh, it did find an index, and it's at index position 1. You can use this function in Python as well. Let's see what happens when it doesn't exist. It's saying, oh, okay, there was an error because that value 8 doesn't exist in this tuple, so it doesn't know what to give you in terms of an index position. Okay, let's try one more thing where we go ft plus, like we did before, tree. Does that work? No, because you can't concatenate a tuple. You can never change the mutability of a tuple. That thing is always as it is. Okay, guys, with that said, why don't we call it? Let's do a quick recap. What did we learn today? We learned, here we are. We learned about lists and tuples, how to do some list manipulation and indexing. We showed you how the indexing works in Python with lists. It's very, very similar to how it works with strings. And then I showed you a handful of functions that you can use with lists. In our next section, we're going to be talking about dictionaries, which are very similar to lists in a lot of ways, except what makes them different is that they're not ordered by position. We use a different type of indexing system. Dictionaries are extremely powerful, though, and are used for virtually all kinds of stuff, and passing information across the internet uses dictionaries, essentially. So they're a very, very useful data type to learn, and I'm excited to show you a little bit more about that in the next class. Catch you then.